Sometimes it does the countdown, sometimes it doesn't. Today it did. First thing that we need to look at is our parent functions. There are 3 starting functions that we are looking at. They are a linear function, so that is just f of x equals x. This is the graph of f of x equals x. This is just a straight line. This is a quadratic function. A quadratic function is a function that is x squared. So something squared, something multiplied by itself. This is an absolute value function. We did absolute value equations first semester. An absolute value function, it's the absolute value of x. So it's the distance from 0. So we have these 3 basic functions. We're going to worry about these 2 for today. And you need to be able to replicate how these 5 points, we're always going to move 5 points, because that's enough to get a good shape of a graph. We're always going to move these 5 points. So a quadratic function starts at 0, 0, because 0 squared is 0. If we were to plug in 1, what's 1 squared? 1. So that's why we have a point at 1, 1. If we were to plug in 2, what's 2 squared? 4. So that's why we have a point at 2, 4 right here. Okay. Moving to the other side, what is negative 1 squared? Positive 1. So negative 1 times negative 1 is positive 1. So that's why we have a point here at negative 1, 1. And then what's negative 2 squared? Positive 4. Because negative 2 times negative 2 is positive 4. So that's why I have a point here. So when you are drawing your quadratic functions, you want to start at 0, 0, and then you want to go up 1, out 1 on each side, and then you can go up another 3 and out 1 to get those ones that are 4 up from there, okay? Your absolute value function, again, we're going to start at 0, 0, because the distance of 0 from 0 is 0. So 0, 0 is a point. What's the absolute value of 1? What's the absolute value of 2? Okay. Then over here, what's the absolute value of negative 1? Distance of negative 1 from 0. 1, what's the absolute value of negative 2? 2. So that's why this one makes a little v, okay? So as we're graphing, pay attention to where I'm putting the points. We need to talk about where we're moving things first, though. So parent functions, our parent functions that we are using, they can be transformed or moved. Today, we are going to transform quadratic functions and we are going to transform absolute value functions. This blank is not big enough. I'm going to write abs value. Abbreviate absolute. Okay, we are not going to transform linear functions because linear functions are so simple in of themselves that we should just graph them using slope-intercept form, which we already know how to do. So we're not going to transform linear functions. Okay, on the Desmos, you guys saw that your graph was moving up and down and left and right. When we are looking at a function written down, we are able to look at whether something is being added or subtracted from the function and whether that's happening inside the function or outside the function. That will determine which of those 4 directions you move. So we are going to fill out this table, and then this table is going to be the most helpful thing to you today until you memorize where everything goes. While you guys are working on your assignment, I will try to remember to leave the table up here. So, if you add inside your function, that is going to move your graph to the left. I would like you guys to write down 2 examples of what adding inside a function would look like. So write down f of x equals, in parentheses, put x plus What do we want our random number that we used to be?
7.
4? Okay. X plus 4. Not necessary. Close your parentheses and square it. So that would be us adding 4 inside of our function. So we're adding it to the x. That will move us left. That will move us left 4. Okay, right underneath that, in the same box, put an example of what that would look like for absolute value. F of x equals the absolute value of x plus 7. Close your absolute values. Make sure that you make your absolute value signs tall enough that they don't look like 1s. That looks like 7 and then an absolute value, not 71. Okay, so that is what adding inside of a function looks like. With this one, in order to have it being squared too, that's why you got to introduce the parentheses. If adding inside moves us to the left, what would subtracting inside do? Yeah, the opposite. It would move us to the right. So we've got f of x equals, in parentheses, x minus random number 15. Close your parentheses, squared. So that would move us 15 to the right. We're never going to do that today because our graphs are not 15 wide. What are you confused about? Okay. Then f of x equals absolute value of x minus number 67. Close your absolute value sign, okay? So that would be us moving to the right a lot. Okay. So moving to the left is us adding inside the function. Moving to the right is us subtracting inside. When you guys were doing your Desmos, you may have felt like positives and negatives were opposite. It's because on the Desmos, the function was x minus h. And so that way the positive h was really getting a positive number that was getting subtracted, so it was really the negative. So don't stress out about that. Don't overthink it. This is what you need to worry about, okay? Adding inside moves you to the left. Subtracting inside moves you to the right. The double negative just gets wonky. Any questions? Okay. So when you do something inside, it's the opposite of what you think is going to happen. Because adding moves you left, which feels negative, and subtracting moves you right, which feels opposite. Feels positive. Okay. Outside our function, that is what's going to move us up and down. This works exactly like you would expect it to work because you're just adding to the function at the end and moving it up or down. So adding outside moves you up. So examples of that would be f of x equals
11.
X squared plus 11 or f of x equals the absolute value of x, and then you need to close that absolute value sign, plus 7 again. Okay, so those would move us up. Right, and then finishing out this little table, it would move us down to subtract outside. So f of x equals just my x squared. What do we want to subtract? 13. Or f of x equals my absolute value of x. Did I just hear a 58? Okay, well, I wrote 58. You can write 38. It doesn't matter. These are just examples. And we're not graphing 58 or 38. We just need to know adding inside or adding outside. And one year I used a number sign, but then people are like, why is there a hashtag here? So I wanted a real number. Okay, so left, right, up, down. Any questions about that? All right, I will put this back up while we are working on our assignment. We need to do our examples on the back, and we'll have to flip back. Well, or we'll flip back a couple times, and then you'll eventually start memorizing it maybe, and not needing to flip to look at the table every time. Okay, the first thing that you are doing is you are identifying each parent function. There are 2 parent functions we're using right now. There are more parent functions, we're just sticking with 2. Then you are going to identify the transformations and graph the transformed function. So zooming into this first one, kind of, we've got f of x equals x squared plus 3. So to find your parent function, you just want to ignore anything that's being added or subtracted. So this parent function is x squared. Then you want to see what's being added and subtracted and where it is. So are we adding or subtracting? Adding. Is it inside my function or outside my function? Outside. So x squared, and then after the squared is the plus 3. So if I am adding outside, then I go use my table, and I say that adding outside moves me up. Okay? How much up is it going to move me? 3, because we're adding 3. So that is going to move everything straight up 3. So let's go ahead and graph that. Any questions right now? Okay, pay attention to how we are graphing this. Take your pencil, put it at 0, 0, move it straight up 3, and put a point. You have to graph your actual points today. You can't just draw a U or draw a V. You have to graph your 5 points. For an x squared function, how you create that shape is from that center point, you can go up 1 and out 1 on each side. Let's go ahead and do that. And then to create the rest of your U, because remember 2 squared was 4, we're going to go up from this point. We're going to go up another 1, 2, 3, and out 1. And up another 1, 2, 3, and out 1. And that will create your perfect little U. Once you get the points there, then you can connect them into the shape of your quadratic. The shape of a quadratic is called a parabola. That's a parabola. Hey, any questions? Okay, moving on to the next one then. We've got the absolute value of x minus 2. I kind of just gave away the answer to the first one. What is my parent function here? The absolute value. It's the other one. The absolute value. Okay, so that's going to be that little V shape. And then, am I adding or subtracting here? Inside or outside? Inside, because it's like inside the absolute values. So I'm subtracting inside, which is going to move me to the right. So if you use your table, subtract inside moves me to the right. So I am moving right. How many? 2. Okay. So then you always start at 0, 0. We are going to move right 2. Put a dot there. Okay, to make your absolute value shape, you're going to go up one, out one on each side. And then go up one, out one again. Just make that little V. And you can connect them. Okay. Any questions right now? What's different about the next one? Roman. Yeah, so there's something being added after the equation. There's something being added after the equation on this one. But there's also something being added inside, yeah? So this one is going to get moved in both directions. So we are going to move this, if you have something inside and outside, and that means it moves left and right and up and down, okay? So parent function still, ignore the plus 5 and the plus 3. My parent function is x squared. I just have my squared there. Okay. Whatever's happening inside is going to move you left or right. Always write that down on your first blank and deal with that first, because it happens first when we're reading our equation. Then deal with the outside one, which is up or down. So adding 5 inside is going to move me to the left 5. I'm just going to write L5. Now that I've got so many things to write, my blanks aren't big enough. And then adding 3 outside, so the plus 3 is outside my function, that is going to move me up 3. So I'm going to write U3. So I got left 5 and up 3. Okay, any questions about that? About how we found those two things? Okay, so then when you go to move in one direction at a time. So start at 0, 0, move to the left 5 and stop, move up 3 and stop, and then put your point. But get your point that you're moving it by where it needs to be before you try to do your graph. From there, I'm doing an x squared graph. So that's the one where I go up 1, out 1, and then up another 3, out 1. So I go up 1, out 1 on each side, and then up another 3 and out 1 on each side. Okay, and then we can connect those into a cool U. All right, any questions right now? All right, let's finish these out then. We've got 3 more. Let's do one more all the way together, and then I want you guys to try them, and we'll check them, try them, and we'll check them. So we've got absolute value of x plus 4, and then the minus 3 is outside the absolute value. So I kind of just told you my parent function's absolute value. Adding inside, what direction does adding inside move me? Left, thank you, Damien. Left 4. Somebody else, what does subtracting, that's adding inside. Adding inside. What does subtracting outside move me? Down. So left 4, and then down 3. So we can graph that one. Left 4, down 3, put a dot. And then from there, we're doing the exact same shape. So we're going to go up 1, out 1 on each side. and then go up another 1, out 1 on each side. Wait, go ahead and try doing the parent, or like filling out the parent function and transformation blanks on this next one. If you want to start graphing, you can. If you want to, we're going to check it before I graph, so you don't want to graph wrong. You have to regraph it. Okay, what is my parent function on this one? X squared, the quadratic. Awesome. What is my first transformation? Right 3. So I'm subtracting inside, which moves me to the right. Okay, somebody else. What is my second transformation? What? Yeah, you're right. 1 up, because it's adding outside. So up 1. So we are going to take our function, start at 0, 0, move it right 3, and up just 1. And then we need to make our x squared shape graph. So up 1, out 1 from each of those. And then up 3, out 1 from each of those. Okay. Last one. Look at it for a second and then we'll talk about it. Hey, what is my first transformation? Oh, sorry. What's my parent function? Absolute value. Awesome. Okay. What is my first transformation? Point the direction I'm going to go. You don't want to talk. Point. Awesome. Right. So we're going right by 4. Then point the direction my next transformation takes me. Down 2. Cool. So right 4, down 2, put a dot, and then make my little V shape. Up 1, out 1, twice on each side. Hey, any questions right now? Okay, glue in your notes, and then I would leave my notebook open to the table because we're about to do a booklet about this to just start memorizing that left, right, up, down, which one's which. So glue your notes in, and then we will booklet about this real quick, and then we'll work on our assignment.